Yes, indeed. It is my pleasure.
It says almost.
Yes.
Right?
Yes, indeed. So it is my pleasure to give you this update about recent activities in the IL Endurance project. So this is my outline. I'm going to start by giving you background to the previous update and upgrade project at IL, the Millennium Program. Then I outline you the activities in the Endurance Program. And then we'll move to the software part, which I'm part of, and I'll show you some future plans that we have and give you a couple of points to take home. So since 1972, way before I was born, ILL started operating high flux reactor, the most brilliant neutron source, continuous neutron source, which is hidden inside the dome, where also there's an experimental hall for hot neutrons. And there are outside guidelines for thermal and cold neutrons in the building here and there. Overall, it runs 40 instruments, scientific instruments, employs 500 people, and now we are running about 1,200 experiments per year. We already underwent a 2-decade campaign of improvements to continue providing this world-class facility for neutron research. And now we are Endurance Phase 2, which ensures continuous output of quality science on 16 updated instruments. Part of that effort is a better analysis software tool for our experiment, but that's a bit of a mouthful, so we call BASTILLE. It's a project that aims to bring full Mantid support to 19 instruments. So the Millennium Program, it spanned from 2001 to 2018. It was a strategy for continued improvement of the infrastructure. So we profited a lot from the technological developments in detectors and micrometers since the instruments were built in the 70s and 80s. And that led to significant upgrades to our guidelines and instruments. Overall, 25 instruments have been upgraded, and the average gain, detector rate gain, was a factor 25. And in the Endurance project, it builds on that investment of Millennium Program. It mostly touches the instruments that were not updated by the Millennium Program. It ensures that IL instruments stay relevant and all the supporting instruments satisfy user community expectations into 2030s. And we want to extend and open scientific opportunities in fields of magnetism, material science, soft matter, biology, and particle physics. With timeline from 2016 to 2023, most projects are complete or nearing completion in the foreseeable future. And there, special attention was made to maintain constant operational budget. So I'm not going to go into details about these instruments, but this is IL-5C, so the hot source neutrons in the dome of the reactor. And so this is one of the guide poles on the side. The point to take home is the instruments marked in amber, which constitute most of it, are updated by the Endurance. So we updated a significant portion of all of our instruments. This is the same case for our 7 instruments, where a number of guide lines and instruments will be either built completely anew or upgraded significantly. So moving on to the phase 1 of the Endurance, which is closed. It spanned from 2016 to 19. So it was partially overlapping with the Millennium Program. It saw improvements in diffraction instruments, spectrometers, indirect and direct time-of-flight spectrometers, as well as elements of other instruments. A number of beam lines have been updated, as well as started a new sample environment equipment development project called NES, as well as BASTILLE, which that was an initiation of software improvements and introduction of Mantid. The biggest gain in terms of instrumentation was by construction of Panther, which has a factor 60 gain in comparison to the instrument that was previously installed in the same spot, IN4. So phase 2, it's currently running, finishing. So with timelines from 2019 to 2022. Most projects are almost done. So it saw updates to small angle neutron scattering, triple axis, quasi-Laue spectrometers, as well as reflectometers and elements of different instruments. Some instruments, an update started later, not in 2019, but 2020, and even later because they were not ready at the beginning of the phase 2 millennium. For example, D007 has only started procuring its position-sensitive instruments, detectors. The cornerstone of NGO's phase 2 was the upgrade to cold neutrons beamline H15, which used to serve 6 instruments and now will serve 6. And the expected gain is 2 to 4 times in the throughput. Also, there's a continued effort to bring new standards of sample environment in ES2 and continue software improvements in BASTILLE 2. Let me now move to the software part. So BASTILLE project aims to provide modern data analysis framework for our users, harmonize their experience inside our facility between different techniques and between facilities, especially useful for users that would like to run an experiment on a continuous neutron source and perhaps also on a spallation source. We decided to replace a common legacy solution, which was LAMP, written in IDL, which became hardly maintainable at some point and a bit outdated. And decision was made to choose Mantid, which was mentioned in the previous talk. And as you may know, it's an internationally developed framework jointly by ISIS and Oak Ridge, which aims for data manipulation, visualization, and analysis. It was found to be the maintainable solution, written in modern C++ and Python, with robust testing and developed according to industry standards or something. So the goal of BASTILLE overall is to bring Mantid support to 21 instruments across various techniques, from small angle neutron scattering, direct and indirect spectrometers, top reflectometers, and polarized and unpolarized diffractometers. And phase 1 saw the manpower of 1 Tesla consultant for 2 years and 3 time-limited contracts for the full time of this phase, so for 3 years. And they handled everything from the initial feasibility investigation through requirement capture of all of these diverse workflows and techniques to development of production quality data reduction, and all in Mantid framework. And they did succeed to bring it to time of flight spectrometers, backscattering ones, scanning powder diffractometers, top reflectometers, and small angle neutron scattering machines, and as well as contribute to the general Mantid development. Phase 2, which is currently running, nearing completion by year end. So 1 senior developer coming from the previous team of part-time contracts and 3 time-limited contracts, I'm one of them. The goal was to consolidate and improve existing code developed during phase 1 and promote future and further adoption with our users. We had to implement workflows for the remaining instruments, remaining 9, and decided to also develop a common graphic user interface for data reduction for ILL drill, and as well as specialized solutions either found necessary, which eventually they were, and now under development we have Scan Explorer for one of our instruments. We wanted to extend the tools for raw data visualization with Raw Data Explorer, as well as plotting with Superplot, and support event mode and kinetic data measurements, as well as participate in the global improvement of framework, notably in the instrument view. So to achieve these goals, we had to develop new and upgrade existing algorithms, and some of them were IL focused. So we developed notably several auto-process algorithms, which streamlined the data reduction process and our interface to our data reduction GUI. Each time we add a new instrument, we had to develop a dedicated Nexus loader in C++, which we did for polarized neutrons for D7, strain with salsa and diffractometer, recently failing extreme D, as well as extend the capabilities of our existing loaders to take into account possibilities for reducing scan measurements for direct geometry spectrometers. We added the component separation of polarized neutron cross sections via specialized bespoke algorithm written in Python and NumPy, but we intend to make it more general in C++ available for everyone in Mantid. There were also some general purpose algorithm we developed, and notably I have to give two examples with Stitch, which replaces two algorithms, Stitch 1D man in 1D, version 3, which is now more bespoke to reactor source needs such as ours, and generate logbook, a Python algorithm for automated electronic logbook generation from our Nexus metadata. And this is one of the examples of issues that we had to deal with. So we implemented during phase 1 data reduction for D11, which you can see on the left-hand side. It was a nice square instrument with 256 by 256 pixels, and the reduction exists for that. And suddenly, well, it's not that sudden, it was all planned, but this instrument is replaced by an upgrade, D11B. We have two side panels, the granularity changes, and we need to add the loader and the reduction workflow for that, as well as for the legacy solution for benchmarking purposes and for the future reduction. So we needed to work with the changing hardware the entire time. We needed to work and develop new workflows. On the right-hand side, you can see a complete workflow for sample reduction of polarized neutron data currently implemented for D7, but will be extended to other instruments at ILL. We implemented workflows for kinetic sums and strain measurement, and just outside of just the reduction, we implemented continuous integration and deployment of our local branch using GitLab CI pipelines and Docker, and soon we'll deploy it with Singularity on Visa. Right now it's using Debian packages. So a number of GUIs were developed. One of them is Drill, which is a spreadsheet GUI used to reduce large number of samples, specifically used for sums. It interfaces to autoprocess algorithms, so when a user chooses their instrument, an appropriate loader, and autoprocess algorithm will be fetched, and columns will be filled accordingly, and all the options can be then specified that are relevant for that reduction. There is a two-way communication, so there's validation, so if user types in something that doesn't make sense, the row will be marked as red, and the useful tooltip will be displayed. If everything is correct, after processing, it will be marked with green, and yellow is for processing. So currently it supports small angle neutron scattering, direct geometry time of flight, and reflectometry, and it's all implemented in PyQt and Python. Another one is RDX, so Raw Data Explorer. It allows for browsing directory tree and visualize raw data just with one click. And so when a user just chooses one of those files, a most adaptive visualization will be selected per technique. And if one is not selected, it will default to instrument view. It was found to be most useful for our users when they come in the morning after a night of getting data and they want to quickly check, do sanity checks on their data without full data reduction. And this we hope to merge in Mantid soon. It's available in our local branch, and we are undergoing testing for actually quite a long time. And there are two smaller GUIs. The one is Superplot on top left. It's used for quick overplotting of multiple curves. So it's possible to choose a column or a spectrum of a workspace and then just go through all available columns and rows for that, add more curves, remove them, and it will be keep overplotting very dynamically. And it's very useful too for finding new peaks and comparing them throughout different energy changes. Another one is Scan Explorer, which you can see on the bottom left. It's an aid for data reduction and analysis for multi-layer scans at D16. What it does, it's finding a center of mass within the region of interest. Both of them are written in PyQt and Python. There's also a minor work widget workspace calculator intended to ease use of binary operations on workspaces by our users that refuse to work on dialogues and scripts. So our future plans, we need to now consolidate and maintain all the IL algorithms that were developed during phases 1 and 2. We want to continue implement new features and quality of life improvements for our users within reason and available manpower. Notably, it would be great to have automatic filling of drill table for entire experiment. It's hard to ask a user to fill 1,000 lines by hand, but this is currently ongoing and we already have good progress on that. And the next step would be to have automatic data reduction in near real time. Naturally, we want to keep contributing to the Mantid project within our resources, which will be 2 permanent developers. And outside just of the software, the intergovernmental agreement convention for ILL has been just extended last year, almost to the day, up to 2033. So we hope to exist and be relevant into 2030s. And part of that, as a European project, Field 2030, the future of the IL beyond 2030, which will provide extra funding. So a couple points to take home. So IL positions itself to support superb neutron research for users into 2030 with 16 instruments already upgraded, constructed, or finishing the upgrade. And with the average gain of an efficiency of factor 10. This program is on schedule despite the pandemic and our human resources disruptions linked to that, and not. And otherwise, Mantid is already implemented on 19 instruments across main IL techniques out of 21 foreseen for this stage, and the future works will focus on maintenance and developing just extra features like this automatic reduction. This is all what I had for you today. Thank you. Questions?
Dominik. Right. Yeah. Andy, you've got one, yes.
How do these GUIs fit into Mantid? You showed a number of applications. Are they part of Mantid or not?
Yes, they are. They are interfaces inside Mantid. Well, some of them are interfaces, and for example, this superplot. So this is just. I'm clicking the wrong thing. So this is the regular plot window you have in Mantid, and which you can normally see your distributions. You can fit them, or you can initiate this superplot feature just by clicking this button. So it fits into, in this case, in that window. This is an interface specialized for ILL. So you need to select interfaces and go through ILL, and it's then opens a small window to just fetch the data, and then it transforms itself into this form. Quite familiar if you know Slice Viewer. And this is the same for drill actually.
Yeah, so Robert had kind of some number for the fraction of budget they allocated for software upgrades in comparison to building Target Station 2. And do you have an idea of what the... I know
the budget for BASTILLE is 2 million euros, certainly for phase 1. And the running budget of the institute is about 100 million euros. And the endurance is below 40.
Okay. Okay. Any more questions? Not the case, then thanks Dominik again.